All right, so you should have your yellow card out also. And today we're going to look at the double angle identities, which are just a little bit farther than halfway. Everything under that we're not going to use at all. But again, I just kind of wanted you to at least be able to see everything, so don't try and apply anything that we haven't talked about. So we'll look at just the double angles today, like we just looked at the sum and difference yesterday. And then we'll end up putting it all back together again. Everybody in here, I forgot to check when the bell rang. You've all taken that test that was from before spring break, right? Just making sure that I'm pretty sure that I caught everybody. Okay. So with your double angle identities, that means that we have sine 2 theta instead of just sine theta, or it could be sine of 2x or sine of 2 alpha, whatever. If it's a double angle for sine or tangent, you just have one option of how you could restate it. For cosine of the double angle, you have 3 options, which really we could get away with just one because it is just a substitution of the Pythagorean identity, which kind of changes it up a little bit. Okay, you make sure, yeah. So the what you picked up, the homework got copied on the back. So make sure that you're looking at the notes side of this so that you're not confused. Yeah. So what we're going to do is when we're done, you'll be able to finish this before you leave. Once you finish it and you check it, you can just show me that you did it, and I'll mark you off, and then you can tape it in. Okay. I was going to recopy it, and then I forgot because some of my copies got done wrong. All right, but so they're up here, but they're also, make sure you can also find them on your card here. So when you substitute these in, if you're going to substitute, if you look at number 2, we have sine 2 theta and cosine 2 theta. So just like everything else, you want to do one thing at a time because you're not really sure what's going to happen. And I would always choose to leave cosine 2 theta till the end if I had more than one thing to substitute in, just because I have options there and maybe I can choose a better option. Okay, and maybe you're not going to know which one's the better option. That's okay too. But in number 1, so if I leave it to last, the only thing to really do here is substitute in for cosine 2 theta. Any one of the 3 I use, it's fine. It will get me to where I need to be eventually because I can substitute in some other things. But I'm thinking by looking at these 3, the one I probably would want to choose the least would be the second one, because if I have cosine squared theta minus, and then I end up with minus 2 sine squared theta in there, then that's just going to cause some other issues. But here I'd be able to subtract away a cosine squared. And here, in this case, it would leave me with just all cosine squared. So I can just kind of decide between those 2. So we'll just do them both so you can see how they both work out. So let's do the first one first. So we have cosine squared theta minus. Now I'm going to substitute something with more than one term. So I'm going to open my parentheses. And this will be cosine squared theta minus sine squared theta. Okay. So when I simplify that, cosine squared minus cosine squared, those zero out. And then I have minus a negative sine squared, which just gives me sine squared theta. Everybody okay with that? All right, so let's say that we had chosen the third one instead. So we would have cosine squared theta minus, and then that would be 2 cosine squared theta minus 1. Okay. So from here, cosine squared minus 2 cosine squared would give me what? Negative cosine squared theta. It's like x minus 2x gives me negative x, right? It's the same thing. And then minus a negative 1 would be plus 1. So isn't that the same thing as 1 minus cosine squared? And when you look at your chart, what's 1 minus cosine squared? Sine squared. So you end up in the same spot, and so you may be thinking, oh, well, I liked the first one better. Well, that's great. That would work out nicely if that's the choice that you made, but you're not always going to, and you don't need to spend 5 minutes over analyzing what to do either. Just do it, and And when you get to a point, because like even if we did the second one, we could get there, but you just have to not stop. When I was grading your test, there were some of you that were on the right track, but then you either stopped or you made up math, okay? There were so many of you, like enough for me to be able to say this, that totally made up stuff, and I know you know better. I understand that the fact that this has trig in it, it makes it look harder. You think it's harder, but I think some of you are trying to make it harder than it is. So just a little side note here. There was one of the questions, and I know this isn't exactly it, and it doesn't really even matter, but it was something like, you don't have to write this down, but secant theta plus secant theta, I don't know, tangent theta. I don't know what it was. It doesn't even matter. But, and from this step, multiple people, like, again, I saw one and I was like, and then it just like kept happening. That somehow this magically turned into 2 secant theta, tangent theta. What you need to remind yourself is that your algebraic steps don't change. This is the same thing as x plus x times y. If you have this, are you allowed to add the x's? No. And you know that, right? And you've known that for a long, long time. But then when it looks like that, you start to make things up. Don't make things up. Treat them like the variables that you've always seen, all right? Here, I could factor this out, and then this would leave me with 1 plus y, right? Which means this makes no sense, but I could factor this out, and that would leave me with 1 plus tangent theta, right? That part makes sense. This, adding these 2 secants, doesn't make any sense. So make sure that you are not making up stuff as you go along, okay? Remind yourself that your algebraic, and then I know this isn't it because this doesn't really work out into much, but just remind yourself about the algebraic steps so you're not making things up, all right? All right. So here, let's look at number 2. All right, so like I said, we're going to substitute for 2 different things so that we are going to, we'll start with the sine of 2 theta, all right? We'll just substitute that first. So this is 1 minus cosine 2 theta over, so sine 2 theta is the same as 2 sine theta cosine theta. Now, is it also the same thing as 2 cosine theta sine theta? Can you multiply in any order? Yes, so it's fine either way that, pops up. The other thing that I saw that made your works, for some of you, impossible to follow was that if you're just going to work with the numerator or just work with the denominator, that's fine, but you have to rewrite the whole thing. You can't just rewrite pieces randomly and then put it all together at the end. That is a misuse of equality, and that's bad, real bad. Okay, so now I have this 1 minus cosine 2 theta in the numerator. So I'm thinking, if I substitute, so all I'm substituting in is for this second part right here. If I substitute that first one in, that would leave me with actually 3 terms in the numerator, right? Wouldn't it be nice if we could get it down to 1 term? So both of these have a 1 in them, both of these second ones here. It'd be nice if this one could subtract out the other one, right? Which one of these would I substitute in where the 1 would get subtracted away? The second one, right? Number 2, like if we call them 1, 2, 3. This one right here, because this is 1 minus. So I think we're going to do that 1 minus 2 sine squared. I think I like that one the best. So this is going to be, the denominator is still 2 sine theta cosine theta. And then this was 1 minus, open my parentheses, 1 minus 2 sine squared theta. So my denominator is still 2 sine theta cosine theta. In the numerator, that 1 minus 1, those are going to zero out. And then I have minus a negative 2 sine squared, so this will be 2 sine squared theta. Okay. Everybody with me so far? If you're going to cancel something out in a fraction, the thetas have to match. Like if this was sine 2 theta down here still, like if I hadn't substituted that, I couldn't cancel one of the thetas with this one right here. Like the arguments have to match. But these are fine. Right here, I can cancel out the 2's. And then this sine theta can cancel out with one of those. So that leaves me with sine theta over cosine theta. And what's that? Tangent theta. What questions we got? We good? Okay. So when we look at number 3, there's not a double angle here, but I can still simplify this. And I know that I can make tangent into sine over cosine, but I don't know that I necessarily want to start there. Remember your denominator, we would really like our denominator to be one term if we could. So is there something that we could substitute that 1 plus tangent squared theta? What could we substitute for that? You gotta look at your chart, not stare at me. Secant squared theta? Yeah. You look at your Pythagorean identities, 1 plus tangent squared is what? Because this isn't the same thing. This isn't the same as that up here, right? It doesn't match this. It looks similar to this, doesn't it? Is it the same? No, because there's a plus down there, not a minus. So I can't just say it's tangent 2 theta, right? But instead, if you look at your Pythagorean identities, we can make this 2 tangent theta in the numerator over secant squared theta. All right, it's one of your Pythagorean identities. So at this point, it's good that each has one term, but I think I'm going to have to use my reciprocals and my quotients here. So I know that tangent is sine over cosine, so I'm going to leave the 2 in the numerator, so 2 sine theta over cosine theta. And then what is secant the reciprocal of? Cosine, so this would be 1 over cosine squared theta. So I have a fraction and a fraction. Is this a keep, change, flip situation? Are we trying to simplify or are we trying to get rid of the denominator? We're trying to simplify, right? We're not solving. So since I'm trying to simplify, it is definitely a keep, change, flip situation. So I have 2 sine theta over cosine theta times cosine squared theta over 1. Then I can cancel cosine with one of those. And this gives me 2 sine theta cosine theta. Shirt is writing for me. So remember when we finish, we have to have it into one single trig term. So I'm almost done. What could I substitute for 2 sine theta cosine theta? Sine 2 theta. What questions you got? Okay, so you have 4 questions on the back to do. The key is over there for you to check yourself. Now, if you go check yourself and we don't match, don't spend too long looking at what I did. Instead, just go, oh, we didn't match. Go back and try and figure it out on your own so you're using your own brain cells. That's the only way you're going to get better at it. Just say, oh, I didn't do it right. That's fine. I'm going to go back and retry it. And eventually, if you have to follow what I did, that's fine. But remember, I could have gone about it a different way, too, because there's some options here. Doesn't mean what you did was wrong. Okay? We good? All right, and then just show me when you're done.